Hi Algebra, welcome to our Flipping the Classroom little studio here. Tonight I'm going to do an example of the distance formula for you, and I can use the distance formula to find the distance between any two endpoints on a line segment. So here's my line segment, and I've got the first point has an endpoint of -3, 1. The other endpoint has an ordered pair of 4, 5. So I'm going to put values into the distance formula so I can find out what the length of this line is here, the length of this line segment, or the distance of it. So I'm going to put in the x-coordinate of point 2, which is 4. 4 minus the x-coordinate of point 1, which is -3. And I'm going to square that. Now let's add that to the y-coordinate of point 2, which is 5, minus the y-coordinate of point 1, which is 1. We're going to square that. Remember that all of this is still under the radical sign. So the distance equals all this, and let's simplify it a little bit. 4 minus a -3 is equal to 7. So I've got 7 squared. 5 minus 1 is 4, and we'll square that. All of it's still under the radical. So now I have 49 from the 7 squared plus 16 from the 4 squared. All of that's under the radical. And all of that, excuse me, that all equals the square root of 65. 65 is prime, not prime, but it contains no perfect squares under the radical. So we would leave our distance as the square root of 65. And that would be your answer. Okay, so what do you do if you want to check this? And I know some of you asked about this in class. You said, can't we just count them up? Well, in this situation we can, because we have a situation where it's on the graph paper and we can count. So I've dotted in the legs of a right triangle here. And all I did was count up the units. So I've got 1, 2, 3, 4, and that's one leg. Now I've got another 1, 2, 3, 4, 5, 6, 7. I've got 7 on this leg. So I put those values into our formula for the Pythagorean theorem. A squared plus b squared equals c squared. And I solved for c. 4 squared equals 16, 7 squared equals 49. We still have the c squared. I took the square root of both sides to solve for c, and I got the square root of 65 equals c. Remember, if this was a Pythagorean theorem problem with a right triangle, this would be c. I can use that to check my distance formula that we got a few minutes ago. And they check. Let's do one more example of the distance formula. This time I have a line segment with endpoints -2, -2, which I'm calling point 2, and then the other endpoint is 4, -5, and I'm going to use that as point 1 this time. So here's our distance formula. I'm going to go ahead and fill this out. The x-coordinate of point 2 is -2 minus x-coordinate of point 1 is 4. We'll square that. Y-coordinate of point 2 is -2 minus the y-coordinate of point 1, which is a -5. We'll square that. Put it all under the radical sign. So -2 minus 4 is actually a -6, right? So let's square that. Then I've got a -2 minus a -5. Well, I'm going to add the opposite here, and that's going to give me 3 squared. Still under the radical. So I've got -6 squared is 36 plus 3 squared, which is 9, all under the radical. So now I'm left under the radical is 36 plus 9, and we know that equals 45. But now at this point, I'm going to look for perfect squares, right? And I can see that if I rewrite this, that 9 times 5 is equal to 45. 9 would be our perfect square, so I can pull that out of the radical as a 3, and the distance is 3 times the square root of 5. In order to check this, I would dot myself a little right triangle here and count up the sides. So we'll call this leg A, and I've got 1, 2, 3 units for leg A. 3 squared. This leg would have 1, 2, 3, 4, 5, 6 units. We'll call that leg B. And what we want to know is the hypotenuse, which is c squared. For the 3 squared is 9 plus 6 squared, 36, equals c squared. So 36 plus 9 equals 45, which equals our c squared. And we'll square root both sides to solve for c. And I get the square root of 45 equals c. Again, I look for perfect squares. 9, sorry, a little sloppy there. 9 times 5 equals 45. So I can pull out that 9. And I'm left with 3 times the square root of 5 equals c, which is what we got a minute ago, so that checks. I hope this one helped you.